Have you ever just stared at a graph and all you see is, well, a line? What if I told you every single one of those lines is actually a picture with a secret code hidden right inside? Well, in this explainer, we are going to become code breakers. So you've probably spent a ton of time in math class taking an equation, something like y equals 2x plus 1, and carefully plotting it out to draw a line. But here's the real challenge, the fun part. Can you do it backwards? Can you look at the picture of a line and figure out the exact secret code, the equation, that brought it to life? Well, that's our mission today. All right, here's our game plan. First, we'll get the hang of this whole hidden equation thing. Then, I'm going to give you a super simple two-step toolkit. After that, we'll practice cracking a few codes, I'll point out some common mistakes to watch out for, and finally, we'll see why this stuff matters for everything from, you guessed it, graphs to galaxies. You ready? Let's do it. Okay, so let's jump right in. The main idea here is actually really straightforward. Every single straight line you see on a graph is just a visual representation of a specific algebraic equation. Our job is to be detectives and translate that picture back into its secret language, that famous old equation, y equals mx plus b. So how do we actually do this? How do we crack the code? We're going to use a really simple method I like to call the two-step toolkit. Seriously, it's all you need to unlock that y equals mx plus b equation from any straight line, just by breaking the puzzle into two easy little pieces. First up in our toolkit is the letter b. That's the y-intercept. And all that means is it's the point where our line crosses the vertical y-axis. The easiest way to think about it is as your starting point. And here's the trick to never forget it. B is where you begin. Simple as that. Next up is M, and M stands for the slope. The slope just tells you how steep the line is, and we figure it out using a little formula called rise over run, which is just how far you go up or down, and then how far you go across. So if B is where you begin, then M tells you how to move. So here's the whole game plan in a nutshell. Step 1, find B, where you begin on that vertical line. Step 2, find M, how you move from that point. And step 3, just plug them both into y equals mx plus b, and you've written the equation. That is it. See? Not so bad, right? Okay, now that we have our toolkit, it is time to put it to the test. Let's get our hands dirty and solve 3 different lines together. Each one's got its own little quirk, so it'll be great practice for our new code-breaking skills. Let's take a look at our first example. Step 1, find b. You can see the line crosses the y-axis right here, at positive 1. So boom, b equals 1. Now for step 2, the slope, m. Let's start from our b point and find another nice clean point where the line crosses the grid. Ah, there's 1. To get there, we rise up 1, 2, and then we run to the right 1. So our rise over run is 2 over 1, which just simplifies to 2. And now for the final, satisfying step. Let's write out the equation. We just pop in the numbers we found. Y equals our m of 2 times x plus our b of 1. And there it is, our solution. Y equals 2x plus 1. First code, cracked. All right, on to line number 2. Step 1, B. Where do we begin? The line crosses the y-axis way up here at positive 3, so B equals 3. Got it. Now for M. Starting from that point, let's find our next clean spot on the grid. Ah, but notice this time, we have to go down 1 and then to the right 2. And because we went down, our rise is actually a negative 1. So our slope is negative 1 over 2. Time to put it all together. Y equals our slope, which is negative 1/2, times x, plus our y-intercept, which is 3. So the final equation is y equals negative 1/2 x plus 3. It's kind of cool, right? That little negative sign in the slope perfectly tells the story of a line that's heading downhill. Okay, last practice round. This one looks a little different, doesn't it? Step 1, where does it begin? If you look closely, it crosses right at the very center, the origin, and that means our b value is just 0. Now for m. From that starting point at the origin, we go up 1, 2, 3, and we run to the right 1. So our slope, rise over run, is 3 over 1, which is just 3. So when we go to write the equation, it would technically be y equals 3x plus 0. But, in algebra, we always want things to be as simple and clean as possible. And since adding 0 doesn't actually change anything, we just drop it. The final, best answer is simply y equals 3x. You are doing an awesome job. Now, before I send you off to crack codes on your own, let's talk about a couple of really common traps. Think of these as expert tips to keep you from making those little mistakes that can trip anybody up. The single biggest mistake people make, hands down, is calculating run over rise instead of rise over run. It's a super easy trap to fall into, right? Because we read from left to right. But you have to remember, slope is all about measuring the vertical steepness, so you always have to calculate the rise, the up and down part, first. The other thing that gets forgotten all the time is the negative sign. So here's a foolproof check you can do for every single problem. Just ask yourself, looking from left to right, is the line going downhill? If the answer is yes, then your slope absolutely, positively must be negative. Always do that final check for the minus sign. It'll save you a ton of headaches. So we've been cracking all these codes, but you might be thinking, okay, cool, but why does this actually matter? Well, this skill goes way beyond your math homework. It's literally the key to understanding everything from predicting how the stock market might move to tracking the path of a comet through the galaxy. Just think about a classic physics experiment where you're plotting how far an object has traveled over a certain amount of time. In that case, the y-intercept, b, isn't just some random number. It's the object's actual starting position. And the slope, m, that's its speed, its velocity. The graph is literally telling you a story about motion. And this really gets to the heart of it. It means you can tell how fast something is moving just by looking at the steepness of the line. A super steep line means it's moving really fast. A totally flat line, that means it's not moving at all. You're not just doing algebra anymore. You're reading the story of the world around you. So you see, these aren't just lines on a page. Every single one of them tells a story of movement, of growth, of change. And now that you know how to crack the code, the only question left is this: what story will you find next?